Hey guys, welcome back. So in the last video, we saw how to insert a new node in a circular double linked list. Hope the concept was clear. Now in this video, let's see how does the algorithm for that operation looks like. So the name of the method is insert in linked list. It takes head reference, the value to be inserted in the node, and the location at which the node needs to be inserted. Then we create a blank node and we insert a value in that node. Then we check if the linked list exists or not. If it does not exist, we return an error saying the linked list does not exist. Else, we go to this else if block. So if location equals to 0, that means if we want to insert the new node at the start of a list, then what we have to do? We have to simply update node.next is equal to head. Now what is node.next? Node.next is this reference here, and we have to insert 001 here, which is nothing but head. So this creates a link between node 5 and node 1. Now the next step is node.previous is equal to tell. This is node.previous. We insert 333 here. What is 333? 333 is tell. Why we have inserted here? Because we want to create a link between this node and the last node. Because remember that in the circular double linked list, first node always points to last node and last node always points to first node. Now the next step is head.previous is equal to node. So what is head.previous? Head.previous is this reference. This is equal to node. That means we put 555 here. So this will create a link between node 1 and node 5. After that, we have to update head is equal to node. So we put 555 here. So this creates a link between head and node 5. And this link automatically gets destroyed. Then we say tell.next is equal to node. So what is tell.next? Tell.next is this reference. So right now it is pointing to 001. We say 555 is the one that it needs to point to. So this link gets automatically disconnected and it starts pointing to node number 5. So this is how we create a new node at the start of a circular double linked list. Now let's say if we want to add the new node at the end of the list, then what should be done? So first of all, as usual, we have created a blank node with a value and all. Now we'll come here and see node.next is equal to head. So what is node.next? It is this reference here. We have to put 001 here. So this creates a link between node 6 and node 1. Now the next step is node.previous is equal to tell. So what is node.previous? This reference here. And what is tell? 333. So we insert 333 here. This creates a link between node 6 and node 4. Next is head.previous is equal to node. Now what is head.previous? This link over here. And what is node? 666. So we insert 666 here. So this creates a link between node 1 and node 6. Now the next step is tell.next is equal to node. Now what is tell.next? Tell right now is 333. So tell.next is 001. So we say in tell.next we have to insert node. So we put 666 here. So this creates a link between node 4 and node 6 and this link gets destroyed. Now finally we update tell is equal to node. So we put 666 here. So this destroys this existing link between node 4 and creates a new link between tell and node 6. So with that we have successfully inserted a new node at the end of the list. Now let's say if we want to insert a new node apart from first and last node, then how it should be done. So the step remains same. That is, first we create a blank node and insert a value in it. So we have inserted 70 in it. Now let's say if we want to insert this new node in between node 3 and 4. So the first step is we have to create a loop starting from 0 till location -1. Now what is location -1? Location -1 is node 3. So we start a loop from node 1, keep going towards right. Once we reach node 3, we stop there. So now we have created a temporary reference called TMP, which has the address of node 3, which is 222. Now all that we have to do is we have to update some of the reference variables. So first we update node.next is equal to temp node.next. So what is node.next? It is this reference here. What is temp node.next? Temp node is 222, dot next is 333. So we insert this 333 here. Once we have inserted it, we get a link between node 7 and node 4. Now the next step is node.previous is equal to temporary node. So what is node.previous? Node.previous is this reference. Here we put temporary. So what is temporary? 222. So this creates a link between node 7 and node 3. Now we say temp node.next is equal to node. So temp node is 222, dot next is this reference here. So we insert the value of node here, which is 777. So this creates a link between node 3 and node 7. And this existing link between node 3 and 4 gets destroyed. Then the last step is node.next.previous is equal to node. Now what is node.next? Node.next is this reference. What is node.next.previous? It is this variable. Because node.next is 333 and .previous is this variable over here. So we insert the value of node here, which is 777. So this creates a link between node 4 and node 7. So this is how we successfully inserted a node in between node 3 and 4. So I hope you have understood how to insert a new node in any place in circular double linked list. So now let's see what is the time and space complexity of this algorithm. So creation of a blank node is a constant time operation. Inserting a value in the node again is a constant time operation. Checking if the list is available or not is again a constant time operation. Inserting a new node at location 0 will require a bunch of changes in reference variables. So all of this will take constant time operations. Similarly, if we want to insert a node at the last position, then all we have to do is we have to update some of the reference variables. All of them will once again take constant time. Now if we want to insert the node at any other place, then we have to run a loop starting from 0 till location -1. So in the worst case, this location can be towards extreme end of the list, hence this will take order of n time, because in the worst case we might have to traverse almost all of the nodes. Once we have discovered the temporary reference, after that we have to update some of the reference variables, which will just take some constant time. Now if we add all of it, we get order of n complexity. Now space for this will be order of 1, because we are using some temporary variables here and there, but nothing more than that, which is proportional to the size of the linked list. Hence the space complexity again remains order of 1. So with that we come to end of this video. In the next video, let's see how to traverse a given circular double linked list. Thanks for your time. See you in the next video.